SwayamPrabha. Digital India. Educated India.
Welcome. So, we are going to start another topic, ranking of design solutions. We will be discussing the AHP approach. AHP is analytic hierarchy process. So, today contains framework for evaluating design solutions, then development of comparison matrices, criteria comparison matrix, then step for AHP and ranking of design solutions. So, I hope that we will be able to complete it by 35 minutes of time, and let us start with the first one, that framework for evaluating design solutions. So, now I will relate this to the previous lecture. In previous lecture, we have discussed safety function deployment, and the sole purpose of that safety function deployment was to find out design solutions that will help in reducing the risk to the level acceptable, provided the solutions are implemented. We have given you the total approach, that how you will ultimately come into getting some of the design solutions. And last lecture, with reference to desulfurization plant, we have identified several design solutions, and for particularly hazard 1 and hazard 6, though these two hazards require similar design solutions because they are similar in nature. So, 5 design solutions we have identified, and obviously you may argue with the ability of the design solutions. There could be better design solutions, but that we have discussed in our last class, that there can be alternative approaches, there can be better design, but nevertheless the approach was to help you to find out some of the design solutions. Now, we are assuming that okay, that maybe for a particular hazard to be addressed, there could be different design solutions, that means more than one design solutions, or other way I can say that there could be more than one solutions that may ultimately prevent the accident scenario to happen. So, if this is the case, then you require to find out the best design solution, and that is what is known as ranking of design solutions. So, we have some important assumptions here. One is that from safety point of view, any one solution is sufficient. Suppose you have identified 5 design solutions, and we are saying that with reference to that particular hazards to combat, any one of them are sufficient. It is very conservative and restrictive one, because the design solutions are different and they could have the different potential, but nevertheless I am saying that any one of them are sufficient. So, if you find that no, there are some better solution, fantastic, but this is our assumption for comparison point of view. The reason is, if any one of them are not sufficient to fight for the safety, then that is not a good solution, which you have found out using SFD. So, that is not to be considered. So, as a result, what happened, once you have several design solutions, you require to choose the best one, and you require some of the criteria to have for that comparison. For example, if I consider that I have these 5 design solutions, and I want to select a best one, then there is set of criteria which help you in getting the best one. So, what are the criteria we have considered with reference to design solutions, which are basically interventions. It may be your hardware intervention, maybe software intervention, or maybe humanware intervention, but every intervention that will ultimately lead to improvement in safety, there is a cost involved for implementing the intervention. Now, second is that the intervention should be reliable on one, because it should perform the intended function for which it is developed. So, it should work within the mission time. Then the intervention or the design solution that must be easy to maintain and that must be easy to operate also. So, safety we are another criteria, that how much risk reduction will be done, that we have assumed that it is any one of them are sufficient. So, that is why maybe the safety criticality, that other criteria we have not added, but if you think that no criticality to the system to be added, you can add another criteria also. So, then you will choose one of the 5 design solution which will be ultimately weighted with the criteria satisfaction. That means, the design solution should satisfy the criteria, and at the same time there will be one which is best. So, what we are doing then? Our objective is ranking of design solution obtained from SFD. What are the criteria we are considering? Cost, reliability, maintainability and operability. And I understand that you know what is reliability, what is maintainability and what is operability. So, we have discussed sometimes, otherwise we will again discuss. And then alternatives to be evaluated is nothing but the different design solutions. So, what is the framework if you want to use AHP? So, there will be set of design solutions or set of which are basically set of alternatives. Then there will be set of criteria based on which the alternatives will be evaluated, and your ultimate goal is select the best one. What best one? Best one or best alternative. So, that is what is our framework. Now, let us see that how we will achieve in selecting the best alternatives given several alternatives. So, these are the steps. What is this? First, development of comparison matrices. What is comparison matrices? If you see the framework, at the bottom you found there are alternatives, and immediately above the alternatives there are criteria. So, you have to develop comparison matrix for the chosen criteria, and at the same time you also require to develop comparison matrix for the design solution, each of the design solution with respect to the chosen criteria. What do I mean by this? We have cost, let it be C, then we have reliability, second criteria, we have maintainability, third criteria, and we have operability, fourth criteria. Now, when we choose design solution, irrespective of which solution, which design solution or which alternative it is, but there must be comparison, some weightage with reference to cost versus reliability, cost versus maintainability, cost versus operability, risk versus reliability versus maintainability, reliability versus operability, then maintainability versus operability, or vice versa. This is what is the comparison matrix, where you are putting more importance, which is more important, reliability of the design solution or cost of the design solution, maintainability of the design solution or reliability of the design solution, or they are equal. So, that kind of data you have to gather, and these data are given by experts, because these are very specialized job. You cannot I can arbitrarily put some value and do it. So, this comparison matrix will come from experts. So, usually we consider 5 experts, 3 or 5 or 7, experts and take the then come maybe if you take the average and get the comparison values. Okay, but it is not one expert, it should be more than one experts, preferably 5 experts. So, another one is that suppose now again you have set of alternatives like DS1, DS2 to DS5, DS1, DS2 to DS5. Suppose with reference to, let it be the first criteria, cost, how do you rate these alternatives? So, is DS1 with reference to DS1 the comparison will be definitely 1, but with reference to DS1 and DS2, if I consider that cost is an important, then what is the comparison? Is DS1 is or DS1 is 3 times better than more than DS2 in terms of cost, if or it is the other way around. So, that way you have to develop the comparison matrix. So, after you develop comparison matrix for cost, then you go for reliability. Then once that is done, then you go for maintainability, and finally you go for operability. Means all the criteria, for all the criteria the design solutions will be compared. Okay. So, when you start take any one criteria, the approach is this: select first criterion, for example cost, for the ranking purpose. Select the first pair of design solution DS1 and DS2, DS1 and DS2. Rank DS1 with respect to DS2 for the chosen criteria. That means you will be having some scale, and we will discuss this, the certain scale we will use to get some values. So, then rank DS2 with respect to DS1, and the reciprocal will be the rank given in step 3. Similarly, rank DS1 to DS3, still so long the DS1 with all other with respect to all other design solutions. Here 5 design solutions are there. So, DS1 to DS2, DS1 DS3, DS1 DS4, DS1 DS5 like this. Then next you select DS2, continue the process. Okay. So, what I will do now, I will with example with some scale data, we will see what is this. So, suppose you are interested to get the comparison matrix for the criterion. We have 4 criteria, this side 4. Now, the Sati and Scairns in 1985 from this source, we found the what are the scale, what are the values, relative comparison values you will put. 1 means they are equal importance, 3 means moderate importance of one over another, 5 is essential or strong importance, 7 means demonstrated importance, 9 is extreme importance, and 2, 4, 6, 8 intermediate values between the two adjacent judgment, like in between 1, 3, in between 3, 5 like this. Then reciprocal of the above non-zero numbers, that is the reciprocal of the inverse comparison. For example, cost versus cost, the same thing, it will be 1. Now, cost versus reliability, it is 0.33. What is this? Actually, that means the reliability is 3 times more important than cost. So, that is why the reciprocal is 0.33. Similarly, maintainability is 3 times more important than cost, reciprocal is 0.33. Similarly, operability is 5 times more important than cost, then reciprocal is 0.20. So, in this manner, cost reliability, cost maintainability, cost operability, then reliability maintainability, reliability operability, like maintainability operability, this way you have to find, you put the values. So, let our values are like this. What does it mean? If I take this value, what is the meaning? That means maintainability and reliability are of equal importance. If I take this, what is the meaning? That means operability is 5 times more important than cost, this 5 strong. Okay. So, this manner you will get the values. Who will give the values? The expert will give the values. Then 5 expert, then you just take the average. Diagonal elements will always be 1 because they are comparison with the same criteria. like cost versus cost, we will have to do this. So, this is what is comparison matrix. Later on I will come to the column sum and other issues, but comparison matrix will be created in this manner. Now, with reference to a particular design solution, so what is the comparison matrix you see? So, how many solutions we have? We have 5 solutions. So, DS1 to DS5, DS1 to DS5. So, here the alternatives will be compared with respect to each of the criterion we have considered cost. Now, what is the meaning of the suppose this? That means DS4 cost is 3 times more than DS2 because it is cost comparison. The cost comparison of DS4 is 3 times more than DS2. So, as a result what will happen, that means DS2 will be, DS4 is 3 times, then DS2 will be 1 by 3.33, the reciprocal. Okay. Similarly, if I consider suppose DS2 here, so DS2, the cost of DS2 is 3 times more than DS1. So, then the reciprocal will be DS1, DS2 0.33 again. So, like this DS5, that is 0.25, DS1 is 0.2 times DS5, so then DS5 will be the 5 times, same manner given by the experts. Okay. So, then what we are saying, that we are interested to find out the importance of DS, which can be termed as priority vector x. Suppose now what will be our job? With reference to cost, what is the priority vector for the 5 design solutions? Here they are alternatives. Okay. So, that is basically our job. We want to find out x, which basically talks about, which is a priority vector, which talks about how in terms of cost DS1 to DS5 is prioritized. Some scores you will get. So, here we have used this notation, that is A, this is nothing but the comparison matrix. So, this is A. So, this one is our A with respect to that 5 alternatives compared in terms of cost. So, what is Aij? Each of the elements. So, ith column and row and jth column value is Aij. So, that means if I consider 1, 2, 3, so if I here I equal to 3, j equal to 2. Okay. So, Ij. What is n? N is the here set number of alternatives or number of design solution. So, as you get the comparison matrix A for cost, similarly you can get comparison matrix for reliability, for maintainability and for operability. How many criteria you have chosen? You have chosen here 4 criteria. So, you will be getting 4 comparison matrix. So, A cost, A reliability, A maintainability and A our operability. In addition, the cost itself will be the criteria itself will be compared amongst each other. So, one more will be there, which is that is criteria comparison matrix, criteria comparison matrix. So, if there are suppose k criteria, so you will be having one comparison matrix for this k criteria. So, another is for suppose you have n alternatives. So, that means n cross n that comparison matrix for each of the k criteria. So, ultimately k plus 1 comparison matrix will be there. So, once you have the comparison matrix, then how you will find out the priority vector x, that we will discuss next. I hope you understand. So, there are set of alternatives in our example design solutions. There are set of criteria based on which you evaluate the alternatives, here the design solution, and find out the best alternatives means best design solution. So, what data you require? You require comparison, pairwise comparison data. So, what are those priority comparison data? One is criteria to criteria comparison, another one is the with respect to each of the criteria, all the alternatives pairwise comparison will be made. So, if there are k criteria, one matrix comparison matrix with amongst the k criteria and k comparison matrix for amongst the design alternatives or among the alternatives here the design solution. In our example, there are 4 criteria and we have 5 design solutions. So, in total there are 5 comparison matrix, 4 with respect to each of the criteria for the alternatives and 1 with respect to the criteria, 4 criteria you can that one. Who will give you the data? Data will be given by expert. How many experts you will choose? It is better to choose more than one expert, 3 or 5. Okay. So, what scale you will use? The SATI scale what I have given to you in this slide. So, you use SATI scale. What is the meaning? It is given there. So, once you complete this one, your data is available with you for doing AHP and getting the best solution. Now, we will see the how the best solution is achieved. Okay. So, the mathematics behind AHP, we will not go into the deep of the mathematics, but please understand what is A. A is the comparison matrix. What is X? The priority vector. Then what is lambda max? Lambda max is basically the eigen value of the comparison matrix A. So, why lambda max means you will get a set of eigenvalues. How many eigenvalues? Depending on the size of the matrix, actually depending on the rank of the matrix. If the rank of the matrix is R, then you will have R eigenvalues, R number of eigenvalues like lambda 1, lambda 2 to lambda R, where R is rank of A. So, out of this, the maximum one, usually the way we in eigenvalue decomposition, we find out the first one will be the maximum, followed by the second one, and that is basically the approach. So, lambda max is the maximum one, that is what you want to find out. You will not consider other eigenvalues, only lambda max you will consider. So, Ax equal to lambda max x, this is the equation or which is basically characteristics equation in matrix. Okay. So, you have to find out this equation. You have to first find out the lambda max. Once you have lambda max, you will be able to get the x value. Okay. So, this part is over. You have already seen this is the comparison matrix. X is the eigenvector of size n cross 1, because what is the either in the criteria or alternatives. If there are n criteria, it will be n cross 1. If there are n alternative, it also will be n cross 1, that is the eigenvector, this is the priority vector. And lambda max is the maximum eigenvalue, that I already told you. So, now you may go by eigenvector, eigenvalue, eigenvector decomposition. So, that approach we are not using here. It is very simple approach we are using, which will give you the equivalent result. What you do, because you have a matrix, so you normalize column entities by dividing each entry by the sum of the column, this one. Okay, and then take the overall averages. So, what is it? You just see. For example, this is our matrix A. So, what is the sum? Sum here is 17, here 8.33, 8.33, 2.86, 2.86, sum of the weights what is given here. Now, if you divide each of the entities in this column by this, each of the entities in second column by column sum, third column by third column sum, fourth column by fourth column sum, fifth one by fifth column sum, you will be getting another matrix. What is this? That is what is a normalized matrix, this. So, that ultimately the column sum was 17 and 1 by that, which one is this with reference to cost. So, if you will get this matrix, each of the column entries will be divided by column sum. Then what you do? Then you find out the overall row average. This row average, how many rows will be there? It depends on how many alternatives are there. Okay, row average. So take the average. So this plus this plus this plus this plus this by. So this plus this plus this plus this plus this by 5. This is the row average. Second row average, third row average. So like this. Okay. So that means this is our x priority vector of the design alternatives with reference to cost. Okay. Now, what happened that you have to do some test here. So, you whether the comparison given by the experts, they are consistent or not. So, you ultimately what you do, you have got this matrix and finally, you have found out this average is fantastic. This means x, that priority vector is found, but this is based on the comparison, pairwise comparison given by the experts. So, whether experts are consistent or not. So, this can be judged by this mathematics. What is the mathematics? First, you find out the consistency index. What is consistency index? Is this lambda max minus n by n minus 1. So, n you know, lambda max already computed. So, then what is what you will find out, that there is another index called random inconsistency index RI. So, SATI has given the random inconsistency index for 10 number for n equal to 10, means 10 alternatives or 10 criteria to be compared. So, suppose in our case, so n is 5, then the random inconsistency index is 1.12. So, you have found lambda max and n is also known. Now, then the consistency ratio CR will be CI by RI. CI by RI. This consistency ratio, this should be less than 0.1. So, 0.1, if then it is acceptable, otherwise not. So, let us see whether things are, what is the status now. So, with reference to cost, this is our matrix, comparison matrix. This is the vector, priority vector you have obtained. Now, this A, this is our A and this is x equal to lambda x, okay, lambda x. Now, you are finding out lambda max average of this is 5. So, you know this is there, down lambda max you can calculate how many equations will be there. So, this is basically 5 cross 5, this is my 5 cross 1. So, resultant will be 5 cross 1 and this is also 5 cross 1. So, you will get 5 equations. So, lambda max 5 values you will find out, lambda values. So, that take the average of all those 5 values, you will be getting this. So, that means from this equation, this matrix 5 values you obtain, and first value is 5, second 5.4, 5.04, 5.08, 5.08 like this, because these two 13, you see 0.13, that is why this 5.04, 5.04, these two are same, these two are same. Okay. So, I hope you understand, that means you will be having this 5 cross 5 equations, but you want only one lambda value. So, you take the average, you will get 5 lambda values, you take the average, that will be, that average will be our that lambda max values. So, now lambda max values is 5.05 and our n number of how many, what is the n size of this matrix, 5 cross 5, So, 5 n equal to 5 divided by 5 minus 1, this is 0.01. Then what is Ri for 5? From the table I have shown you earlier, it is random inconsistency index 1.05. What is then consistency ratio? Ci by Ri, this is 0.008, it is less than 0.1. So, consistency criterion is satisfied, So, that means the experts, whatever the data given by the pairwise comparison data is consistent. So, you have to do it for other comparison matrix related to reliability, maintainability, operability as well as for the criteria comparison matrix. So, similarly for the criteria also you will get the normalized these values, because the column sum will be divided by, or each entry of a column will be divided by the column sum, the way we have done for design solution with reference to cost. After that what will happen? So, there are two issues now. One is you have priority vector for the criteria, same manner you have computed, and you have the priority vector for the design solutions, okay, with reference to C, R, M and O. What is this? Let me go back. Point 0.06, 0.06, 0.13, 0.13, 0.34, 0.34. These are basically priority vector for 5 design solution with reference to cost. Now come, देखो. So, what is with reference to your that DS1, DS2, DS3, DS4, DS5 with reference to cost 06, 13, 13, 34, 34. So, these are the priority vector with reference to cost for the design solution. Similarly, you have to find it with reference to reliability, with reference to maintainability and with reference to operability. Now, overall score you have to find out, because the weight priority vector also to be used. Then if you do 0.08 multiplied by 0.06 plus 0.022 multiplied by this plus 0.08 multiplied by this plus 0.42 multiplied by this means this sum will be this. So, then DS1's rank is 0.08. Now, same thing for DS2, that means 0.08 multiplied by 0.13 plus 0.22 multiplied by 0.09 plus 0.22 multiplied by 0.08 plus 0.42 multiplied by 0.09, it will be 0.09. So, again DS3 also, as these values are same, the rank is also same, and DS4, that is 0.34 into 0.08, 0.22, 0.50, 0.28 into 0.38, 0.42 into 0.21, this is 0.33. So, in this manner it is 0.41. Okay. So, now what happened basically, which one is the best, then DS5 is the best as far as this calculation. Okay. So, this is what is AHP, analytic hierarchy process for finding out the best design solution. Please keep in mind that the calculation whatever given here, you please check if there is any mistake anywhere in computing through calculator. So, just rectify it, but what I hope that you understand the procedure, and using this procedure you will be able to find the best design solution. So, few important thing here, that please note that the assumption from safety point of view any one solution is sufficient is too restrictive. Though DS5 is the best, it may not be the idea of that which one is the best, which one is the next best, like this. Again that AHP as good as the data provided by the experts. So, this is the reference. So, I hope that you understand the use of AHP. Please that take a problem or the same problem you solve and practice it. Thank you very much.